Imagine looking up at the night sky, a familiar tapestry of glittering lights. Each point of light tells a story, some spanning millions or even billions of years. For centuries, humans have gazed upward, wondering about the mysteries hidden among those distant stars. Now, imagine one of those lights, a colossal star, hundreds of times larger than our sun, suddenly disappearing, not fading slowly, but vanishing almost without a trace, as if it had been plucked from the sky by an unseen hand. This isn't science fiction. It's a true, cosmic ghost story. Astronomers have long puzzled over stars that seem to simply wink out, leaving behind a mystery that has challenged our understanding of the universe. In a distant galaxy, a massive star ended its life in a cataclysmic explosion, a supernova. This is one of the most powerful events in the cosmos, releasing more energy in a few moments than our sun will in its entire lifetime. For the first time, we witnessed the star just before its final act, thanks to the James Webb Space Telescope. JWST's incredible sensitivity allowed us to capture the star's last moments, something astronomers have dreamed of for decades. This discovery solves a decades-old mystery, the missing red supergiant problem. These enormous stars were expected to explode as supernovae, but their absence in the aftermath left scientists scratching their heads. Astronomers expected these giant stars to explode as supernovae, but could rarely find evidence of them in the aftermath. It was as if these cosmic titans simply vanished, leaving behind empty space and unanswered questions. It was as if the main characters were missing from their own cosmic dramas. The universe, it seemed, was keeping its secrets well hidden. The light from this event traveled 40 million years to reach us, finally arriving in 2025. Imagine, the photons that left that star began their journey long before humans even existed. Scientists rewound the tape, using JWST's powerful vision to spot the star before it vanished. By piecing together images from before and after the explosion, they solved a puzzle that had lingered for generations. We have found the missing giant, connecting theory to reality. This is a triumph not just for technology, but for human curiosity and perseverance. This single observation confirms our models of stellar evolution and sharpens our view of a star's final moments. It's a rare glimpse into the dramatic end of a stellar life, and a validation of decades of scientific work. It's not just about one star, it's about understanding the cosmic engines that forge the elements of life. Every atom in our bodies was once inside a star like this, forged in the heart of a supernova. The universe has just shared one of its deepest secrets, reminding us that even in the vastness of space, there are still wonders waiting to be discovered. To grasp the significance of this discovery, meet the James Webb Space Telescope. Launched in 2021, JWST is a marvel of engineering, a time machine peering back to the dawn of the cosmos. Unlike any telescope before, it captures invisible infrared light, revealing secrets hidden from our eyes. Its massive gold-coated mirror and tennis court-sized sunshield keep it cold and sensitive, orbiting 1 million miles from Earth. From this vantage, JWST revolutionizes astronomy, from exoplanets to the birth of stars. Its latest find, the vanished star, is another jewel in its crown. JWST is our boldest step yet in exploring the universe. JWST's secret weapon is its ability to see in infrared, a part of the spectrum invisible to our eyes but crucial for unlocking the universe's mysteries. Imagine trying to see through thick smoke with your eyes. No matter how hard you squint, everything remains hidden and unclear. But with thermal goggles, suddenly the hidden world is revealed. You can spot objects and shapes that were completely invisible before. In space, cosmic dust acts just like that smoke, cloaking dying stars and newborn stellar nurseries from our view, making them nearly impossible to study with ordinary telescopes. Red supergiants, some of the largest stars in the universe, shroud themselves in thick clouds of dust, making them nearly invisible in visible light and hiding their final moments from astronomers. Hubble and other telescopes, powerful as they are, were blinded by this cosmic dust, but JWST's infrared vision pierces the veil, revealing what was once hidden. With JWST, what once looked like a faint ghostly smudge is revealed as a blazing beacon, a star shining with incredible brightness. This superpower lets astronomers explore hidden galaxies, star nurseries, and even the universe's earliest light, peering further back in time than ever before. By seeing in infrared, we unlock a cosmos that was invisible before. Entire regions of space, once dark and mysterious, now burst with detail and activity. The discovery of the supernova's progenitor star is a perfect example. JWST revealed a truth hidden just beyond the visible spectrum, giving us a front-row seat to the life and death of stars. The universe now appears richer, more detailed, and full of surprises, with every new image from JWST rewriting what we thought we knew. Thanks to JWST, we're not just seeing more, we're seeing differently. The telescope is transforming our understanding of the cosmos, changing how we see everything. Our story begins in the vastness of space, in a spiral galaxy known as NGC 1637, located an astonishing 40 million light-years from Earth. This distant island of stars, swirling with cosmic dust and gas, has long been a subject of fascination for astronomers searching for clues about the universe's most dramatic events. In June 2025, something extraordinary happened. Astronomers detected a brilliant new point of light in NGC 1637, a supernova, which they named SN 2025 Puricht. This sudden explosion outshone the entire galaxy for a brief moment, capturing the attention of observatories around the world. Immediately, a global race began. Teams of scientists scrambled to identify the star that had met its spectacular end, hoping to solve a cosmic mystery that had eluded them for decades. Archival images from the Hubble Space Telescope, though powerful, couldn't see through the thick dust shrouding the galaxy's core. But the James Webb Space Telescope, with its infrared eyes, had already captured detailed images of this region, peering through the cosmic haze. Astronomers meticulously compared images taken before and after the supernova's appearance, focusing on the exact spot where the explosion occurred. There, in the JWST's data, they found it, a massive red supergiant star, glowing brightly before the explosion, and then, in the aftermath, completely vanished from view. This was the breakthrough that they'd been waiting for, direct unmistakable evidence linking a dusty red supergiant to a supernova event for the first time. For astronomers, it was a moment of triumph. At last, they had a clear, one-to-one confirmation of a red supergiant's explosive fate. The mystery that had puzzled scientists for years was finally solved. The discovery, published in the Astrophysical Journal Letters, marked a turning point in our understanding of stellar death and the life cycles of massive stars. It's a milestone that reshapes how we think about the final moments of the universe's most massive stars. The evidence is now undeniable, providing a new foundation for future discoveries. Thanks to the unprecedented vision of JWST, astronomers can now explore the universe's hidden corners with clarity never before possible. With each new discovery, the universe's secrets are coming into sharper focus, revealing the wonders that lie far, far away. For years, the missing red supergiant problem baffled astronomers. Theory predicted these giants should explode as supernovae, but observations rarely found them. The discovery of SN 2025 PAT's progenitor changes everything. JWST identified an extreme, dust-enshrouded red supergiant, one of the reddest and dustiest ever seen to explode. The dust made it invisible in visible light, but not in infrared. The giants weren't missing, they were hiding in plain sight. This discovery validates our models and shows we simply needed the right tool to see reality. Science advances when we build better eyes on the universe. JWST didn't just find the star, it revealed its secrets. The dying giant was 100,000 times more luminous than our sun, shedding its outer layers in a storm of dust. Infrared analysis showed the dust was rich in carbon, hinting at turbulent, powerful processes inside the star. This was no quiet death, but a chaotic, violent finale. The data gives stellar modelers a real-world snapshot to refine their theories. JWST's discovery also highlights the teamwork of global observatories, combining decades of data for one breakthrough. Science is a team sport, and this is a victory for all. JWST elevates the value of every other telescope, connecting the dots across time and light. The universe's story is clearer than ever. The scientific community is electrified by this discovery. For the first time, we have direct, unambiguous evidence of a dusty red supergiant exploding. JWST's data marks a quantum leap, moving from inference to certainty, and this is just the beginning. JWST will uncover many more hidden progenitors, building a complete picture of stellar death. Upcoming observatories like the Roman Space Telescope will join the hunt, accelerating discoveries. Supernovae forge the elements of life: iron, calcium, oxygen, tracing our cosmic origins. By understanding which stars explode and how, we deepen our connection to the universe. We are, quite literally, made of stardust. The universe is dynamic, evolving, and we are part of its story. This is a golden age of discovery. As JWST rewrites the story of stellar death, it also reveals other wonders. Its images of gravitational lensing, where massive objects bend light and magnify distant galaxies, are stunning and scientifically powerful. These cosmic magnifying glasses let us see galaxies, otherwise invisible, even to JWST. The Cosmos Webb program has already identified hundreds of spectacular gravitational lenses. JWST's sharpness reveals details never seen before, turning blurry smudges into intricate structures. Whether peering through dust or using galaxies as lenses, JWST is pushing the frontiers of knowledge. The universe is full of secrets, waiting for us to look deeper. Each new image is a reminder of the vast, awe-inspiring reality beyond our world. The discovery of SN 2025 PHT's progenitor is a landmark, a cosmic ghost finally unmasked. It confirms our theories and showcases human curiosity and ingenuity. JWST is our eye on the invisible, a time machine connecting us to the universe's cycles of birth and death. But this journey depends on public support and investment in science. Our quest for knowledge is vulnerable to earthly troubles, but it's vital for our future. This discovery renews our sense of wonder and reminds us that every atom in our bodies was forged in a star. By studying distant supernova, we read our own origin story. The next time you look at the night sky, remember the hidden dramas unfolding across the cosmos. The James Webb Space Telescope is our ship, and the universe is our ocean. The journey has just begun, and the secrets ahead promise to be magnificent.